Today we're going to be focusing on multiplying binomials, but specifically looking at special cases. Now the big deal with special cases is there's typically a pattern to what's going on. So we're going to have to look for that as we solve our problems today. So first of all, there's a lot of variable conversation up here, so I just kind of want you to watch. First of all, if I tell you that something has a square on the outside, that means that everything that's inside of here, you can multiply that by itself twice. So a plus b, and then the parentheses in the 2 out here means that it's going to be a plus b times each other. Now this part I just kind of want you to get, the first number is going to be squared, the second number is going to be squared, and then whatever these two numbers are, we're going to multiply them together and multiply it by 2 to get the middle case. Now, if you just want to use the normal things that we've been doing to solve, that's fine. But we'll start to talk a little bit more about this pattern of what that looks like by the time we get done. So, if I take this first example, 8x plus 7 quantity squared, I'm actually going to go off on the side here and I'm going to set up my shortcut method for what we've been doing. So, if it's x plus 7 times x plus 7, set up my multiplication in my line here. I'm going to add 1s here just because we said that helps us remember when we multiply to have that there. And also, if having that exponent of 1 there helps you, feel free. And then we're going to start on multiplying with this 7. So positive 7 times positive 7 is positive 49. Positive 7 times 1x is 7x. Now I've multiplied 7 by everything. So I'm going to go to this 1x, which means I add my 0. 1x times 7 is 7x. And 1x times 1x squared, or times 1x times 1x is 1x squared. Nothing like telling you the answer. And then I'm going to total these. So 1x squared plus 14x plus 49. Now let's talk about pattern here. This 1x squared comes from squaring these two. Squaring these two gives you the 49. And then multiplying those together was 1x times 7, and that got doubled here to give you 14. So again, we're just talking about pattern. Okay, let's look at this next one. In this next one, it's 4k minus 3, the quantity squared. Now that means, just like up here, I knew that was going to give me this. I really should have written that out so you'd know that's where this information came from over here. Which means that I know that this one has to be that 4k minus 3 times itself twice. Now I'm going to go ahead and set up my shortcut method, but actually I'm going to make myself a little more room here. So if I go to set up my shortcut method over here, 4k minus 3 times 4k minus 3. So negative 3 times negative 3 is positive 9. Negative 3 times 4k is negative 12k. Going to add a 0. 4k times negative 3 is negative 12k. And 4k times 4k is 16k squared. Now notice we have these kind of doubles that happen in the middle. That's going to happen, these doublings, every time you have a squared here. So that's something important to remember as far as the pattern. This middle total is going to be negative 24k and then 16k squared in front. Now notice this example was specifically chosen because it's a non-x kind of problem up here. So I want you to be able to have a good idea of what to do with those. Okay, so these are based on the ideas of squaring. So on this, example 1 and example 2 are ideas of squaring, where you take the exact same thing multiplying by the exact same thing. Now let's talk about what's different. In this problem, you can see on this example, they're exactly the same, except one's got a plus and one's got a minus. And notice from this pattern up here, what ends up happening. The first number ends up squared. That's what this is. The second number ends up squared, and that's what this is. But notice there's no middle term at all. All there is a minus. So let's take a look at what that looks like with real numbers. So d plus 11, d minus 11. Do my multiplication sign on my line. So I'm going to add these ones in and then start my multiplication. So negative 1 or negative 11 times positive 11 is negative 121. Negative 11 times 1d is negative 11d. I'm going to add a 0. 1d times positive 11 would be a positive 11d. And 1d times 1d is 1d squared. Now in solving this problem, you'll notice that you have exact opposites here, which is what happens when you have that canceling out. So I'll be left with 1d squared minus 121. And actually, if I were to write that, people would write that as 1d squared minus 121. Or remember how we talked about in class, you could drop that 1 in the front, because we assume that 1 is there whether you write it or not. Now in this one, realize what that gives you. This first number squared would be 1d squared. 11 squared would be 121. So again on these problems, this 11 was squared and gave you 121. And notice that up here it just has a minus. That's ended up what happened in our problem, because in our problem we actually had this middle stuff that canceled out. And that's really what this focus of difference of squares is. These would be squaring or identical if there wasn't a difference between the signs. That's kind of how they're named. Okay, let's take a look at just a couple more here. Okay, on both of these are set up to be ones that are squared. So that means I'm going to take what's in the parenthesis and multiply it by itself twice. So y plus 11 times y plus 11. Now just like I did before, you could add those ones if they help remind you, and add the ones of the exponents again if that helps you. So 11 times 11 is 121. 11 times 1y is 11y. Add my 0. 1y times 11 is positive 11y. And 1y times 1y is 1y squared. So this ends up being 1y squared plus 22y plus 121. Okay, let's try this one. On this one, it's going to be 3y minus 6, or 3w, excuse me, minus 6, times 3w minus 6. Now on this one, I don't have to add any ones for exponents, or excuse me, for coefficients, but I may have to add ones of those exponents if that helps remind you of what you're doing. Okay, let me move this stuff up and make us a little room here. So if I go through to multiply this now, negative 6 times negative 6 is positive 36. Negative 6 times 3y, or 3w, is negative 18w. Add my 0. 3w times negative 6 is negative 18w. 3w times 3w is 9w squared. So 9w squared minus 36w plus 36. Okay, let's see if we can hit one more difference of squares problem. Let's see, let me move ahead a little bit here. Let's try this one. This one, the problems are exactly the same, except that one is minus and one is plus. Notice this is also trying to build your knowledge by actually including. So let's explore what happens when this p to the fourth is kind of there. So if I go to set this up just like before, I have p to the fourth minus 8 and p to the fourth plus 8. Set up my multiplication. Now I'm going to add my ones here in front, but I have no other ones to add anywhere else because my variables actually already have an exponent. So positive 8 times negative 8 is negative 64. Positive 8 times 1p to the fourth is 8p to the fourth. I'm going to add a 0. 1p to the fourth times negative 8 is negative 8p to the fourth. 1p to the fourth times 1p to the fourth is 1p to the 8th. Now if I go to add my stuff up, notice that I still have those opposites. So I can tell right now that this piece is going to cancel out. Then negative 64 here and 1p to the 8th here. So that means our answer is going to be p to the 8th minus 64.